Hello, everybody. We're here to talk about IMF, and we're not talking about the International Monetary Fund. This will not be as exciting as NASA. It's a little more practical. It's a bit of a case study. Okay, so my name's Eric King. I'm with the Deluxe Technicolor Digital Cinema Group at Deluxe. And we'll talk about, like I said, the IMF and IMP in general and some of the efficiencies and issues we're seeing with implementation across the board. The volume of interoperable master packages, or IMPs, being created is rapidly growing, along with the desire to fully utilize the interoperable master format, or IMF, for interchange, complex versioning, and mezzanine workflows. High-end mastering tool sets for creating IMPs have quickly evolved, enabling the industry to create IMPs that incorporate the latest asset types and feature sets of the IMF standard. However, cost-effective tool sets capable of proper playback and transcoding of these IMPs for downstream use are somewhat limited or lack the full feature set needed to encourage wider industry adoption across the entire supply chain. The first wave of IMPs being created and distributed have largely been simple base IMPs that contain a single or limited number of composition playlists, or CPLs, but that is rapidly changing as the industry seeks to fully realize the benefits of IMF for complex versioning. To do this, we'll need better downstream tools that not only support simple IMPs, but complex IMPs that utilize both base and supplemental packages with multiple CPLs and a multiple of essence files. Over the course of creating and servicing more than 4,000 IMPs for features and episodics from 2015 through today, and working with major worldwide content creators and distributors on IMP creation and quality control across the US, we have had an experienced vantage point for observing key gaps which might inhibit widespread adoption if not addressed. This case study identifies possible issues and makes suggestions to mediate them in order to move toward an IMF pipeline that supports seamless creation to distribution workflows. Some key points: which version of IMF are most commonly used? How are base and supplemental IMPs being leveraged today, and what are the challenges surrounding them? Any issues in the implementation of current IMF standards and tool sets which need to be addressed. Some common workarounds and approaches addressing those issues today, and suggested approaches for moving forward. The goal of the IMF standard was to develop a specification for an interoperable set of master files and associated metadata to enable interchange and automated creation of downstream distribution packages. The targeted benefits of the format include a single interchangeable master file format, capabilities for automated packaging and delivery, minimized storage requirements for prohibitively large files, complex versioning support, and simplified post-production transcodes. The format was designed to support business-to-business exchange by creating IMPs which contain all the essence files, metadata, and CPLs necessary. The essence files contain any required audio, video, subtitling, and/or captioning data, basic metadata as XML, and the CPLs describing how the essence files should be played back to create specific versions. In many ways, the CPLs function as an EDL. EDL being an edit decision list for anybody who's querying that. After years of conceptualization and standardization, the IMF format has made its way into commercial content servicing and distribution. Over the past 2 years, there have been significant increases in the number of IMPs being created, as well as those being supplied as sources for downstream distribution workflows. This is an example of the number of orders which our digital distribution group received for IMP creation from January of 2016 through July of 2017. As a technical service provider, we've seen tremendous growth in the number of IMPs we've been asked to produce and process. In 2016, our digital distribution group created close to 1,000 IMPs for our clients, compared to fewer than 300 in 2015. Order volumes continue to increase through 2017, up more than 30% so far versus 2016, and continuing the trend this year. While this is encouraging for a format aimed at simplifying the complexity of media servicing, versioning, and distribution, There is still a lot of work to be done and education required to achieve the widespread adoption needed to realize the full benefits of IMF. It's important to understand how early adopters are utilizing IMF along with the challenges they're facing to come up with solutions and improvements to improve usability and increased adoption. The IMF standard has been in development and use for almost a decade, but has only begun to see wider scale commercial adoption over the past 2 to 3 years, coinciding with the realization and maturation of IMF application 2E. This adoption has been driven by several factors that include the introduction of UHD and HDR distribution platforms, delivery specifications requiring IMPs as deliverables, the rapid growth of localized international iterations for broadcast, VOD, OTT distribution platforms, and the development of commercially available practical tools to create and service IMF. These factors have led content owners to begin to utilize the creation of IMF service masters to improve their mastering and versioning workflows. As content owners and distributors began to look at how UHD distribution would impact their infrastructure and workflows, one thing became immediately apparent. UHD master files are much larger than HD master files. The UHD version of a feature film is usually 4 times larger than the HD version, format, codec, and bit depth held constant. Because workflows that may have worked for HD mastering and distribution, such as the creation of a separate HD master for each foreign language version, require a lot more storage when you're dealing with UHD, utilizing the CPL versioning capabilities of IMF to limit the aggregate size of video essence files needed for each title made sense, and its potential to save a lot of space when properly implemented while maintaining high quality, and has driven interest in exploiting the format to maximize infrastructure investments. The rapid growth of international distribution for VOD and OTT platforms over the past few years has brought added challenges to localization and versioning control and strained global localization capacities for subtitled and dubbed content. In 2016, Amazon joined Netflix in its ability to reach nearly 200 countries and territories, requiring vast amounts of content to be localized into languages which they may have not been localized into previously. Aside from language, the global distribution of content could also require an increase in the number of versions created for legal compliance and censorship needs. By leveraging the metadata and componentized functionality of IMF, high-count versioning can be managed with the weight of fewer primary essence files. Several major content owners have begun creating UHD IMF service masters to maintain a high-quality version of their content, which can be transformed into different downstream UHD distribution formats as needed, and able to service distributors which accept IMPs directly, as well as those that accept transcoded variants. In addition, IMF service masters are more flexible and easier to manage than the image sequences from which they are typically made, TIFF, OpenEXR, and DPX, while still serving as intra-frame high-quality sources. HDR technologies have also driven the adoption of IMF. While not exclusive to UHD content, the vast majority of HDR content today is UHD, and IMF has become a preferred format for carrying the HDR metadata within the included XML or the wrapped video essence files. It is currently one of the only ways that Dolby Vision dynamic metadata can be transported via embedding through a distributed service master, though it can be used with other formats as sidecar XML. Delivery specifications requiring IMF have also emerged. Netflix advocacy for IMF and its inclusion of IMF as a deliverable for UHD content is another major adoption driver, rapidly increasing the number of IMPs being created and serviced. While not everyone is making IMF a delivery requirement, it is being added or considered for the delivery specification of an increasing number of distributors. Adoption is expected to increase over time as IMF applications continue to be developed and expanded to support additional use cases and essence file formats, for example, App6. Lastly, the emergence of both commercial and open source IMF software has facilitated more accessible IMF creation and servicing. The most functional of these tool sets are higher-end mastering applications that can be expensive to implement, but that may change as adoption increases and innovations like microservice implementations come to the fore. However, the current limitations in downstream repurposing tools have affected the types of IMPs being created and serviced from. So this is just a quick snapshot that's hard to read because it's white on a light background, but about the force of the international distribution explosion. So the main points being added challenges for localization and version control. Amazon and Netflix now able to reach almost 200 countries and territories. The increased number of language versions, legal compliance and censorship versions, high count versioning control with few primary essence files when done correctly, an IMF service master. As an example of this, there have been a few titles this year alone where we've had to do 384 versions off of the OV. So whether it was because of language, dubs, subs, blurring, edits for legal or censorship, 384 versions for a single title. And so just some points about the first wave of commercial IMPs. Interoperable master packages being created have largely been simple base IMPs. So OV, all self-contained, no dependencies. Limited number of compositions playlists per title. In other words, people are not fully exploiting that for versioning needs. More complex IMP support is needed for complex versioning. Base and supplemental IMP with multiple CPLs and a multitude of essence files. Deluxe has created over 1,000 IMPs for feature and episodics in 2016 alone, indicative of burgeoning volumes. Seeing common adoption trends and common challenges across the industry, things that get in the way of adoption or the implementation of automation. Okay. So this is an example of the relationship between base and supplemental IMPs, where the base IMP contains an original version or OV CPL with OV essence files, and then supplemental IMPs containing foreign language CPLs and essence files. Base IMPs aren't always OV, but the figure above is reflective of how many programs utilizing base and supplemental IMPs today are arranged. So you can see on top, that would be your fat base that has everything in it, full vid. Everything down below is localized for Italy, Germany, France, Spain. And ideally, all you would have in the supplemental IMPs below are the deltas. So you would have language tracks, you would have subs that were different, or any edit inserts, and you would render out only that so that the CPL in the new supplemental IMP references both the base IMP and itself, but doesn't give you a full payload. So if in a mathematically lossless base IMP for UHD, the full size was 3 terabytes, your exported supplemental IMP to version it might only be 2 gigabytes. Let's see here. While we're seeing an increase in the number of IMPs being created, many of them are simple base IMPs that do not leverage the full capabilities of IMF. Of the IMPs ordered from us over the past 24 months, 80% of them have been base IMPs, which typically contain the original version of the program. Supplemental IMPs that reference the base IMP to create localized or derivative versions haven't gained as widespread traction for distribution and are currently being used less frequently by content owners. IMPs containing complex CPLs, CPLs with multiple edits and essence inserts to create alternate versions are even more rare, accounting for less than 5% of all IMPs being created or serviced from in our experience. So this is an example of the way IMPs can be implemented, the red being the inserts. To date, the majority of IMPs being created consist of primary texted video, video with on-screen titles, and forced narratives included, and audio essence with full subtitles and captions often being burned in or included as sidecar, non-internet media, subtitles and captions, IMSC1. Some contain simple CPLs for head and tail builds, but as mentioned above, complex CPLs are still relatively rare. To create localized IMPs, many are creating textless inserts that are layered on top of the primary texted video via a CPL to create a pseudo-textless generic international version that can then be rendered out to a localized foreign language IMP with foreign language subtitles. In that case, each foreign language version contains a fully rendered primary video essence. Conceptually, it would make sense to create a base IMP that contains a textless or pseudo-textless primary video essence, which could then be utilized to create supplemental IMPs that contain subtitles and narratives to derive the foreign language texted versions without creating a new primary video essence file for each version. Unfortunately, downstream compatibility issues with IMSC1 captions and subtitles are a considerable barrier to effectively utilizing this more progressive base supplemental IMP workflow. Many of the downstream transcoding tools that support IMP as an input do not yet properly interpret IMSC1 files and result in texted versions that do not match the formatting intended by the content creator. Because of this, early adopters are sometimes having to burn in their subtitles or include them as sidecar non-IMF formats to ensure that foreign texted versions are available to be rendered as intended. There are several challenges surrounding wider adoption of IMF as the preferred service master format for distribution workflows, as well as the implementation of the full functionality of the format. Interoperability continues to improve, but we'll need more fully interoperable tool sets to widen the base of users and more users to solidify the interchange advantages of the format. Incorporation into distribution specifications is dependent on ease of servicing and will need both for the format to gain more traction. An examination of commercially available downstream transcoding tools illustrates the need for better IMF support. We saw inconsistent results using 4 basic criteria: single-tile J2K support, multi-tile J2K support, base CPL support, and supplemental CPL support. Of the 10 tool sets evaluated, only 4 supported all 4 criteria without additional user interaction, and 2 did not support any of these fundamental functions. Better solutions are on the horizon from several vendors as of NAB, so we are optimistic on this front. As a side note, we also compared 4 IMF mastering tools, so not downstream transcoding tools, and found that they all support these 4 core functions. In fact, they did such a good job, they actually made it too easy to create bad relationships that would still work upon imports. They're almost a little too forgiving on the mastering side. Real-world inconsistencies can be demonstrated by file structure alone. In the more robust systems, one can create CPLs, which reference files in one merged folder. CPLs, which reference files residing in a nested folder structure, folders within folders, or side-by-side as siblings. The mastering-focused tool sets have little issue understanding these file hierarchies and easily work within these methods. Unfortunately, if you then try to open the same CPL using another software tool intended for repurposing or transcoding, it may only work with CPLs referencing files in a single merged folder. This means that before the CPL even leaves the facility it was created in, you're already running into compatibility issues simply opening the playlist. Thankfully, it's easy to create an IMP that merges all the files into one merged folder for increased downstream compatibility, but not all users follow this process. So nested or side-by-side folder structures are often created and interchanged with other facilities without merging, potentially creating downstream problems. Many users prefer nested and side-by-side folder structures for human readability and content curation and would like to see them supported in more tool sets so they don't have to export merged folders to ensure compatibility. Some users insist that nested folder structures are also critical for their own DAM and MAM systems and feel that flexibility in its support is imperative for IMF to be successful. IMSC1 interchange and formatting issues, as mentioned earlier, are another implementation challenge. Until there is more demonstrable consistency in IMSC1 rendering and solutions for the issues of rubies and HDR, users may be forced to continue to burn in text for their language versions, limiting the adoption of supplemental IMPs. The development of IMSC 1.1 and IMSC 2 will address most of the current limitations of IMSC 1, but downstream usability should remain a focus. Though improving multi-tile J2K support for IMF players is another barrier to adoption. There are several IMF players on the market that only support single-tile IMPs, again potentially limiting the types of IMPs which can be created to ensure interchange compatibility. This one can be a bit frustrating because if you don't know whether you have single-tile or multi-tile and you're feeding the CPLs to a player and it's playing some of them, it's not playing others, it can be inobvious why it's not playing. So it's just something to look out for and ask for in terms of player support for anything you're planning on using. Another IMF feature that is rarely used is the output profile list, or OPL, which can contain the technical transcoding and reformatting instructions for a specific format or delivery specification. Of the nearly 4,000 IMPs which we have created over the past 30 months, none have utilized OPLs for secondary outputs or modifications. This is likely because there aren't currently any downstream systems capable of interpreting them well, if at all. This is somewhat to be expected given the stage of commercial adoption, but it is another feature which carries great promise in terms of automation, facility, and has yet to be fully realized. The utilization of pan, scan, and scale controls are another aspect which shows promise, but are infrequently utilized when creating IMPs and not yet well supported by downstream transcoding tools. Descriptor metadata tags used to describe essence files has also been limited. Many early IMPs haven't fully exploited the descriptor functionality, but that is changing with some content owners rapidly adding more descriptor metadata to extend informational record keeping. In general, it's very encouraging to see the increased production of IMPs, but why aren't users embracing the full functionality of the format? As software options increase, compatibility issues are addressed, and interchange improves, users will begin to take advantage of the full functionality of the IMF format and begin to leverage its extensive capabilities. Until then, the benefits of the format will be somewhat constrained, and its appeal won't be as apparent to those considering it. It's exciting to see the adoption of IMF in commercial distribution workflows with significant year-over-year growth. The extensive file management and versioning capabilities of the format are a welcome feature in a world of increasingly large master file sizes and growing localization requirements for content owners and distributors. However, today's early adopters are forced to somewhat constrain the features they exploit due to limited tool sets and interchange issues. More full-featured software options are needed to provide better interchange and solutions defined for proper texted and file structure interchange, as well as OPL support for users to be able to truly realize the format's promise. With the continued participation of technologists, vendors, and users across the SMPTE organization, these hurdles can be overcome to increase adoption and bring the benefits of IMF to more users around the world. So that's the end of the formal presentation. Do people have questions? Go ahead. So this is App 2 and App 2E. It's J2K specific. So each one of the apps has its own codec and kind of rule set. The other app I mentioned, which was 6, is not fully ratified by SMPTE yet, but it will be a QuickTime. It'll be ProRes, will be the codec in that one. Anybody else? Yes.
Many of the codecs, traditional workflow, they don't support directly the IMP. So like the text codec and then wrap it up with the IMP or MXF or...
So MXF is the wrapper that holds the essence itself. The IMP is basically the folder that contains all of that. You can just pull the MXF itself and try and deal with it directly and ignore the CPL. The problem is that any edit instruction that was in that is now lost. Any of the metadata that was in it is now lost. So once again, we're going away from the automation that we would hope this would bring us, because you're back to simply manually submitting a file and doing your own edit points. So while it can be done, it's going in the opposite direction from where we want to go with this. Go ahead. Well, the way you could exploit the OPL is you could actually turn it into the final, you could use it to go directly from the J2K that's in the IMP to the deliverable that's going into someone's home. So if I had this thing sitting up here at UHD, and we'll say it was at 2398, I could repurpose that. I could do a pan and scan from that. I could scale it. There's all kinds of things I can do with the OPL. It's not that it can't be done manually. But why, if I could set that up beforehand and address all of the known outputs, why wouldn't I just put it there, feed it to a system that can actually understand that, and I can just walk away?
So in that case, would the OPL be created by the receiver
It could be, so when somebody's creating the master, it could be created there. It could be updated upon receipt at the other end. Anybody can modify that once it's done. They just need the tools to get in there and do it. Yeah. Go ahead.
You mentioned file size being one of the challenges.
Yeah.
Do you know of any efforts to support HEVC and IMF?
It's, so trying to be codec agnostic within that, because at the end of the day, it's just a wrapper, right? So I should be able to put that in there. It's being contemplated. It's not been ratified by SMPTE yet in any way, but it's being discussed. If you're looking for something that's a more efficient codec.
Well, I make codecs, right, but including HEVC.
Yeah.
And I'm just curious why we would use something that's like lossless J2K. It's not even motion J2K, if I understand correctly, right? So every frame is encoded uniquely as an iframe, essentially.
Exactly, yeah.
Same with ProRes, right?
Yep.
That's great if you need it to be random access like you're doing editing, but as a delivery package.
So this is functioning more as a mezzanine, right? So
I don't need to edit it. It's a final production package.
yeah.
I just need to transcode it later, right? So
Yeah.
I can use interprediction. We could reduce those file sizes massively. Is there any technical limitation of HEVC that you're aware of that would prevent it from essentially upgrading IMF?
Well, so it wouldn't be an upgrade. It would be an additional app is the way it would come in. So it would live, if we're going to have apps 1 through X, it would sit there as one of those with a different codec repped in.
Yeah, I mean, my term upgrade was
Yeah.
enhance the capability to allow the same quality to be delivered at much better file sizes, right? Much smaller file sizes. We could use HEVC 10-bit or 12-bit 444 lossless with interprediction and probably reduce file sizes by a factor of 3.
Yeah, I would agree with you on that. Now, bit depth-wise, for the HDR, especially the Dolby content, we tend to keep that up around 16 bits. We don't drop down to 12 for that. So when you're talking about the mathematically lossless way, remember these are serving more than one purpose. So if a studio is coming in at the top of this at mathematically lossless, then the mezzanine they're going to use is going to be a sub of that, which is probably main level 6, sub level 4, sub level 3, so it's quite a bit smaller at that point. Your bit rates are down around 800 megabits per second. So as you drop down through, you could service off 12, but you're holding off 16, which is almost acting as an archive, right? Because I mentioned the replacement of the image sequences. So whether you want to dump TIFF, OpenEXR, or DPX, if you have that mathematically lossless 16-bit sitting there, you could theoretically use this as an archive candidate.
Right, but again, we're talking about a mezzanine delivery package.
Yes.
12 bits should be more than sufficient that is then decoded, transcoded essentially, right? To
Yeah.
Delivery distribution
Yep.
bit rates, right? So there's nothing about 12-bit that's going to result in any visible difference in the 10-bit HDR encodes that Netflix and Apple and Amazon and Hulu and Vudu and Sling and everybody in the world.
Yeah. But it's not only be used for streaming, this source would also feed things like UHD-BD, which in Dolby is going to be a 12-bit because of the enhancement layer. So we do preserve for that. I mean, we can talk about different flavors of it, and certainly 10-bit is a candidate, and we do it for SDR all the time. And it's not just me, I don't own this. I mean, this is something that anybody can use. It's in tool sets out there. You can use any of those descriptors as you choose to implement them. As far as bit depth goes, whatever you think will work for your use case, it's available.
I'm just scratching my head as to
Yeah.
why HEVC hasn't been adopted sooner.
It's being discussed, and largely it's not widely used as an iframe implementation, and that's kind of how, at least in concept, this has been looked at so far. A lot of, especially the mastering tools, don't do real well with long GOP structures, so as far as parsing them go. So I think it'll get there. It's just not there right now.
Okay.
Yeah. Anybody else? Okay. Being told that's it. So thank you.